Today I'm talking about binomial expansion. A common misconception is that a plus b squared equals a squared plus b squared. Now, that is not true. No, scribble it all out. It's all wrong. No, it's terrible. We can work out a plus b squared with grid multiplication. It's quite a simple method, and it's probably one of the most popular methods for squaring and such like. For the purpose of squaring, we just put a here, we put the first term here and here, and the second term here and here. To work out each box, we multiply the number at the top of the column by the number at the far left of the row. So this box would be a times a, which is a squared. This box would be b times a, which is ab. This box would also be ab. And this box would be b squared. And then we just add all the boxes up, so it's a squared plus b squared plus, that's just 2ab. That's alright for squaring. But when we move into higher powers, it becomes quite difficult. So let's work out a plus b to the 3, or cubed. We would take the results of this grid and again multiply it by a and b. A and b here, and then these terms go here. And then to work out each box, we again multiply it. So this would be a cubed, this would be ab squared, this would be 2a squared b, this would be a squared b, this would be b cubed, and this box would be 2ab squared. And then to total it up again, we add all the boxes. So a cubed plus b cubed. Now we have 2a squared b and a squared b here, so it's 3a squared b. And then we have 2ab squared here and ab squared here, so that's 3ab squared. You can see this is getting pretty tedious. So, what is a better way of doing this? Well, we have to use something called Pascal's triangle. The way Pascal's triangle works is you start with 1, and to generate each number, you add the two numbers above it. So here would be 1 plus nothing, here again would be 1 plus nothing, so it's 1. Here would be 1 plus nothing, and again over here, and in the middle is 1 plus 1, which is 2. Again, we have 1's over here and here. 1 plus 2 is 3, and again here. Let's just go on to the fourth layer. Bear in mind that the first layer is called the 0th layer. So 1, 4, 6, 4, 1.
And what is this triangle actually used for?
Well, Jake, now, if we come back to a plus b cubed, the way we're going to work this out is using the third layer, and this is going to tell us the number of terms that we have and also the powers that each term has. So let's start with 1. We have 1 times a to the 3. We bring the first number and we raise it to the power that we're raising the whole thing to. And then we put in the second number and raise it to 0. The next term is, we have 3 of the next term, so 3 times, then we have the first number again, and raise it to 1 less than before. So 3 minus 1 is 2. And then the second number, we raise it to 1 more than previously, so b to the 1. The next layer is again 3, so 3 times a to a power 1 less than before, so a to the 1. And b to the power 1 more than before, so b to the 2. Finally, we have 1, and we finish it off with a to the 0 times b to the 3. As you can see, this goes 1, 3, 3, 1, like the third row in Pascal's triangle.
And it's the third row because we're raising to the power of 3, right?
Yeah. Now let's simplify this down. So, multiplying by 1 doesn't affect it. So we have a to the 3. And any number to the 0 is 1, so we're again multiplying by 1, which doesn't affect it, so we can ignore that b to the 0. Then we have 3 times a squared, 3a squared, times b to the 1, which is just b. Next we have 3 times a to the 1, which is just a, times b squared. And finally, multiplying by 1, which doesn't make a difference, a to the 0, which is 1, which doesn't make a difference, and b to the 3. We know this is right because this is the same as the answer we had from the grid multiplication, only that it's ordered slightly differently. So this would work for layers other than 3. So as I said, these are the third layer of Pascal's triangle, and if you were raising to a different number, then you would just go down to that layer of Pascal's triangle. And as you can see here, we're going from a to the 3 down to a to the 0, and b to the 0 up to b to the 3. And if we were raising to a different power, we would just go down from that number to 0 and up from 0 to that number. So that was binomial expansion, which is just an easier way of raising two numbers to a power.